Howdy, my name's John Goodling, and this is episode 2 of my boat project with my brother. So, the last episode we talked about the rules, regulations, limits, constraints, things like that, and now we're going to get into the meat and potatoes of it. So, the first thing that I knew I needed to do before I could design a hull or think about the engine was work on getting an impeller or a jet pump. So, I decided to look on eBay and I found a Berkeley 12 JCA jet drive. This probably came out of a 70s era sportscraft race boat, something of that nature. It's capable of about 500 horsepower, and most importantly, it's very cheap. I also wanted to get one that was capable of having trim control, which they don't come stock with, but this is the one that I got. Had to drive to South Carolina to get it. Cost me about $1,300, and it was in pretty rough shape. So once I got it home, I bought a rebuild kit for it and started taking it apart. So ignore this engine for now. That'll come in later. But once we took it apart, I noticed we had this shoe where it came in from the bottom, and that's where it takes the water out. And then it spits it out the back through a hole. So I started uh, just taking it apart, and this is what it looks like more apart. So you can see we've got the trim control, steering and reverse bucket. There's the bowl with the stators in it, so when an impeller rotates, it will put a tremendous amount of spin on the water, so those stators straighten all that water out, so it doesn't impose that too much on the boat. It still has torque, but not as much. There's the impeller, and the part that is missing out of here, but you can see clearly in this picture, is the shoe. And this is the intake, basically, for where the water comes in. So I'm going to come over here and show you where I modeled that in uh, SolidWorks. So this is exactly what it looks like. And the most important thing that I needed it for was this radius right here. Now, that radius allows me to design the first part of the hull, the bottom. So that's what I started to do. And you can see here that this is what I ended up with, and this is what I essentially started with. So we can go into the sketch, and you can see that I modeled that radius precisely based off of the other SolidWorks drawing for the intake rate, which I got from the actual part. So I reverse engineered it in a way. The second consideration that I had was dead rise. Dead rise is the angle from the bottom of the hull to the water, so to the water line. So in most sprint boats, that would be about 20 to 25 degrees, but that introduces some problems with chine walking, which is where the boat becomes unstable in its rocking direction. It allows you to rock as the water line drops because you're going faster. So I reduced that to about 17 degrees. I also wanted to be able to turn corners very, very aggressively without sliding in the water. So I made the chines 2 inches long and made them have negative rake. And what that means is normally they would be level with the water level or with the water line, parallel with the water line, but I made them come down and inwards, and that means that it'll grab the water if it ever banks hard enough to actually turn. And then the rest of this was taken from references from other boats. So the sidewalls come out to a total length of 5 feet, so it's 5 feet wide in total, and it's 2 feet tall, which seemed like a good number compared to what everyone else was doing. I took some reference pictures offline and I used them to generate that hull design. So I also looked at the rule book and it says that our maximum length is 14 feet, and I decided to go for about 14 feet. So if we just get out of here, I can show you I made some planes, made some reference features, and I made it look like a boat. So I made a shape that looks like a boat. And then from there, I was able to take all of these parts and generate DXF files from them, uh, which I then sent off to a plasma cutter and ordered up a series of sheets, which I could weld together. And these are old pictures that I took uh, of what I wanted it to be like, what I envisioned it looking like from the get go. So I made a quick reference model for the roll cage, the engine, and the rest of the boat, and took a couple of screenshots of it, and that's what I wanted it to be. While I was waiting on all of these parts to come in, I took some scrap stainless steel and made a rock grate. So this goes on the inside of the intake and it prevents rocks from coming in. So that's what you're seeing there. That's a side view of it. And then that's what it looks like in real life. So back to the hull, I have a bunch of pieces of aluminum that I cut out, and I made the transom and the bottom part and the chines uh, quarter inch, and then the rest of this stuff was 11 gauge. So this is how it came to me from the plasma cutter. And importantly, I kept all of the scrap metal. I asked for that specifically because I knew that we would have some extra pieces that we needed to cut out and weld on. So I and my brother started to weld this stuff together. We were limited by the size of the plates, so we had to weld some out flat or weld some back up flat. And this is Will getting a bit of a welding tan, but we had to weld along the bottom, and then that's what it looks like after we tacked it up on the bottom, and then we mounted the transom, so we achieved that curve that matches that intake, and we just ratchet strapped it together and welded that transom. And you can see we were having a bit of trouble because we had an air gap right there. And so what we did was we ratchet strapped from the top to the bottom and pulled that air gap tight and then tacked it all in place. And then from there, we just took each individual piece because I knew where they each belonged and we tacked them into place. The reason we tacked it was so that it could still move after after we had put it into place, because each one of these pieces uh, built up stress along itself as we bent it into place, and that would kind of shift everything, and we wanted to be able to bend everything. We also ended up strapping it to a log so that we could bend the nose down, just so we could force it into place, and it ended up being all of these members ended up being in a lot of stress, but that was kind of by design, as that would I figured that would strengthen it, and because we use such thick material, I didn't have any gussets or any flanges in between to support this. It's a self-supporting structure. And we just continued to weld. We added some parts and pieces, but we ended up making it look pretty boat shaped. And then at the very top, because of all of those stresses, each part at an angle, the next piece up took the stress from the other one and transferred it into itself. So if we had put a piece along the top, we probably could have gotten these little buckles out. But just because of the heat and the manufacturing process, these buckles ended up forming, and we ended up getting rid of them by cutting V notches in each side and then welding it flat. So these buckles eventually got out, but this is what it looked like on the ground, fully tacked into place. So then we flipped it over, and you can see the hood on the ground, but we didn't have the need for that yet. We fully welded all of these seams on the outside and then ground them back. And you can see that we got it really flat. And you can also see that intake part matches that curve pretty closely. And I was very proud of that because it fit in there almost perfectly. And you can see there's a hole in the back where the water would come out. And I'm very proud that all of this stuff ended up matching pretty perfectly. I didn't have to do very much modification to any of this stuff. These corners ended up a little bit rounded because of the plasma cutting process, but that didn't take but 30 minutes to get this whole thing fitted in. And then to attach it, what we ended up using was riv nuts. So I put holes along each of the there's a hole pattern in this plate, and you can see that I countersunk holes for a riv nut, epoxied a stud in place, and then I bolted this piece to the bottom of the hull. And what that means is that it's an extremely strong connection. It's a very secure uh, attachment. And these are all 1/4 inch stainless steel studs. And then we flipped it back over, installed the rest of the jet pump, and that was the majority of the hull done. This probably took um, about a month to do, working probably 4 hours every day in the Alabama suns. And you can see that we got the sidewalls completely straightened out, and we got it mounted up onto a trailer, an old trailer that we had. And this was just us admiring it. It was very cool to see this part of the hull come together. So that is episode 2. And next episode, we'll talk about the engine and engine performance. So thank you.